Let's try to put a memory chip to the maximum. This is what it looks like when the memory chip is enlarged. This is one of the storage units in the storage array, called the EPEC storage unit, which is only a few tens of nanometers in size. It has two parts. One is the capacitor for storing binary data, and the other is the crystal tube used for reading and writing data. The capacitor is made up of two layers of inductive material. When the capacitor is charged to 1V voltage, it will write in the binary 1. When the voltage is 0V, it will write in the binary 0. And the binary 1 and 0 are obtained through this crystal tube. A single crystal tube cannot work alone. Only by connecting several crystal tubes can a working crystal tube unit be formed. A basic unit consists of at least two crystal tubes. Its basic function is to convert the input 1V voltage to 0V when it is output, and to support reverse rotation. This is the most important function that can execute the binary 1 and 0. Let's disassemble one of the crystal tubes. These are the key parts inside the crystal tube, which are the mounting pin, the hook, and the capacitor used for isolation in the middle layer. It is an important ring that controls whether the current passes through the hook or not. In addition, there are metal pins on both sides of the hook and the mounting pin. These pins input and output the current through the metal hole. When the mounting pin is charged to 1V, the current can flow through the hook, connecting the two sides of the hook. When the mounting pin is charged to 0V, the current cannot pass through, causing the two sides of the hook to be isolated. Due to its mounting structure, it is called the N-shaped flat field effect crystal tube. Now let's add the second crystal tube, which is called the P-shaped crystal tube. Its operation is exactly the opposite. When the mounting pin is charged to 1V, the current cannot pass through the hook. When the mounting pin is charged to 0V, the current can flow through the hook. The N-shaped crystal tube is equivalent to a normal faucet. When the switch is turned on, the water flows. When the switch is pressed, the water flows. The P-shaped crystal tube is exactly the opposite. When the switch is pressed, the water flows. When the switch is turned on, the water flows. Now let's connect the mounting pins of the two crystal tubes and combine the mounting pins of the input terminals into one. In this way, when one pin is charged to 1V or 0V, the two crystal tubes can be controlled at the same time. Due to the opposite characteristics of the two crystal tubes, when the mounting pin is charged to 0V, the P-shaped crystal tube is turned on and the N-shaped crystal tube is turned off. When the mounting pin is charged to 1V, the state of the N-shaped and P-shaped crystal tubes will be reversed. The N-shape allows current to pass and the P-shape blocks the current. Next, we connect the power circuit and the ground circuit on the upper side of the crystal tube. We keep the power circuit at 1V and the ground circuit at 0V. Then we add two pins to connect it to the metal pins of the crystal tube to form a partial circuit of the standard unit. Now we mark the input on the island line that shares the mountain level and mark the output on the other island line. At this point, a complete anti-aircraft crystal tube is formed. When we apply the 1V voltage to the input terminal, the voltage will be transmitted at the same time to the mounting pin of the two crystal tubes and cause the N-shaped crystal tube to turn on and the P-shaped crystal tube to turn off. As the channel of the N-shaped crystal tube opens, the 0V voltage of the ground circuit will cross the hook channel and finally reach the output terminal through the metal hole and the island line. The function of the anti-aircraft crystal tube is to convert the 1V input into 0V output. The 2V input of the computer is made in this way. It is worth mentioning that although the distance between these islands is only a few nanometers, they are all wrapped up by a so-called anti-aircraft insulating material and there is no interference between the lines. This is the basic function of the crystal tube unit. Scientists have also designed more and more complex crystal tube structures to realize many complex functions such as calculation or storage through different connections.